In this video, I'm going to go over using the rational root theorem. This is another video showing that. So we're going to find all zeros of the following function. We're going to do that by factoring. So the first thing we're going to want to do with this is we want to write out our P and Q list, so a list of all possible zeros. So I'm going to start with P. P comes from the constant in the back, and we want all of the factors of the constant. So all factors of 6. So 1 times 6 will give me 6. Then increase 1 to 2. 2 times 3 is 6. And there's no other factors there. So 1, 2, 3, 6 is all the factors of 6. Then I'm going to find all my factors of Q. Q comes from my leading coefficient. My leading coefficient is the number in the front of my polynomial, which is 2. So the factors of 2 are 1 and 2. So what I'm going to do is I'm going to make my list of P divided by Q. And this list is going to be positive and negative. I'm going to take every single P I have up there and divide it by all of my Q's. So I'm going to do 1 divided by 1, which is 1. 2 divided by 1, which is 2. 3 divided by 1, which is 3. 6 divided by 1, which is 6. And I'm going to repeat that process, but for my other Q. So 1 divided by 2 is 1/2. 2 divided by 2 is 1, which I already have. 3 divided by 2 is 3/2. And then 6 divided by 2 is 3, which again I already have. So this list right here has all of my potential real zeros. So my real zeros, they're going to show up in this list. So what I need to do is I need to find one of my zeros that actually works. And the way we go about doing that is we're going to take our entire polynomial and we're going to plug it in to our calculator. So I already did it for this problem. I went to y equals, did 2x to the 4th plus x cubed minus 14x squared plus 5x plus 6. I already plugged it all in. And you can look at the graph, which that's great. More importantly, what we want is we want the table. So I'm going to hit second graph, which takes me to my table. Now what I'm looking for is I'm looking for which x values give me a y value of 0. And you'll notice there's several. So I'm looking for x values that give me a y value of 0. So I have -3 gives me 0, 1 gives me 0, and 2 gives me 0. I'm going to start with 1. I like to work with small numbers. So if I use 1, I'm going to do synthetic division, and this is going to show that 1 is one of my zeros. So I'm going to do synthetic division of this polynomial. So I'm going to have 2, 1, -14, 5, and 6. So I'm going to do synthetic division here. Add down, multiply up. So adding 2 down, 2. Multiply by the box. 2 times 1 is 2. Add down, you get 3. Multiply up by the box, you get 3. Add down, -11. Multiply by the box, get -11. Add down, -6. Multiply up, get -6. Add down, we get 0. So what we notice is my first, I just proved that 1 is a 0 because I got a remainder of 0. So since I had 1 in the box, my factor is going to be x minus 1. So looking at this, this would represent, since this was x to the 4th, this would be 2x to the 3rd plus 3x squared minus 11x minus 6. That's not something I want to factor. So what you can do is you can go back to your calculator and use another point that gave you 0. So I already used 1. I see I have a lot of other options here, so why not 2? Let's use 2. So I'm going to do synthetic division with my answer from earlier, and I'm going to use +2 as my next synthetic division. So I'm going to add down, multiply up again. So I get 2, 4, 7, 14, 3, 6, 0. So I just do synthetic division again. Be careful when you do it, because if you make a mistake, it can really screw up the entire problem. So I showed that 2 also works as a 0 because I got a remainder of 0. So since I have 2 in the box, my factor is going to be x minus 2. Now again, I could look here, I have 2, 7, 3. So that would be like 2x squared plus 7x plus 3. That is something that we can factor, but at this point in the semester, there's a lot of kids that really forget how to factor, especially using the box method. It's still a skill that you want. Factoring is definitely a skill you want. But I'm going to show you that, we'll say what if come test time you forget how to factor. Well, what you can do is keep going back to that list. So I've used 1, I've used 2. If there's another number that works that gives you 0 for y, use it. So I've used 1 and 2. If you go up here, I see that when x is -3, I get a y of 0. So I'm going to keep going. I'm going to use -3 now. Do synthetic division again. So I bring down the 2, multiply by the box. Add down, multiply by the box. And you'll see I get a remainder of 0 again. So -3 works. So since -3 worked in the box, my factor is going to be x plus 3. So since -3 worked, x plus 3 is going to work here. So, and if you couldn't hear over the announcement, I did the synthetic division. -3 was in the box, so you get x plus 3 there. So I'm down to 2 numbers. If I change this back to polynomial form, it's just going to be 2x plus 1. Well, 2x plus 1 is a completely factored piece. That is actually going to be my final factor here, 2x plus 1. So what I have up here is my polynomial completely factored out. X minus 1, x minus 2, x plus 3, and 2x plus 1. The only thing left to do is take every single factor, set them equal to 0, and solve. So if when I have x minus 1, I'm going to get x equals 1 as my answer. When I have x minus 2, I'm going to get x equals 2 as my other 0. When I have x plus 3, I'm going to get x equals -3 as my 0. And then 2x plus 1, that was a little bit harder to see. When you have 2x plus 1, set that equal to 0. What you're going to do when you solve is you subtract the 1. So then you're left with 2x equals -1. Divide by 2. And we get x equals -1/2. So all of my zeros are right there. X equals 1, x equals 2, x equals, that's a -3, and x equals -1/2. Notice all of these numbers show up in this list. Keep in mind this list is positive and negative. So I have my 1, 2, -3, -1/2. So that was another example using the rational root theorem.